This is Ben McGahee with Yamie Chess. I'm going to be your math teacher today. Yamie Chess is the math learning aid based on classic chess that helps students in math and science education for school. In this lesson, we will learn about binary and decimal numbers. So, the numbers that we use every day are in the decimal system, known as the base 10 system. And those digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are the digits that we use in the decimal system. Now, on the other hand, the binary system was created to do computer technology, or to develop computers. And it's called a base 2 system, so it only has the two digits 0 and 1. And so if you see these four light bulbs over here, you see that the 1 with the yellow light being on, that represents the on switch for the light bulb. And then for the 0 represents an off switch for the light bulb. So we have 1 being on, 0 being off, 1 is on, 0 is off. So the way you would read this binary number would be 1, 0, 1, 0. So the decimal system is base 10 system with the 10 digits 0 to 9, and then the binary system is a base 2 system with the two digits 0 and 1. So let's look at how to convert from binary to decimal. So there are a few rules that we need to know. We have the powers of 2. We're going to write those down from right to left, as we see here. So we start at the rightmost digit, so 2 to 0 power is 1, and then we go to the first power is 2, to the second power is 4, to the third power is 8, and to the fourth power is 16, and then etc. So the best way to remember this is you just start with the number 1 and then you double each time. So 1 doubled is 2, 2 doubled is 4, 4 doubled is 8, 8 doubled is 16, 16 doubled is 32, 32 doubled is 64, etc. And then the next rule says to add up all the powers of 2 that have a 1 in that spot. So only the ones that have a 1 or the the on switch. And then the zeros or the off switches do not count, so we're not going to add those. So we're only going to add the numbers that have the on switch or the ones to find our decimal number. So we're going to convert 1101 to decimal. So let's write that number down. So we have 1101, and we'll convert this to decimal. So we'll have our spots here. So we write our powers of 2. We're going to have 1, 2, 4, 8. And then the ones that have 1 in them, we're just going to add those together. Circle the ones. So we have 3 ones. And then those powers of 2 we're going to add together. So the 8, 4, and 1. So we're going to do 8 plus 4 plus 1. So 8 plus 4 is 12, plus 1 is 13. So the binary number 1101 is 13. Okay, so we're going to do the reverse process now. This is from decimal to binary. Decimal to binary. So this process is a little more challenging, but it does require a few rules to follow, which is kind of more of a repetitive process, so you have to repeat a few times. And so the rule is to divide the number by 2. And the reason we divide the number by 2 is because binary is a base 2 system. So we're using the number 2. And then we're going to record the remainder after we divide. And then we're going to divide the quotient, the value that we get with dividing by 2. And then we're going to repeat these 2 steps here until the last remainder becomes a 0. And then we're going to write all the remainders from top to bottom. So this is a repetitive process where you have to divide over and over again, write the remainders down until you get 0, and then you stop. And then we write all the remainders from the bottom to the top. So let's see how this works in an example problem. We want to convert 49 into binary. 49 into binary. So I have 49 divided into 2. And what we're going to do is I would like to separate this into like 2 important columns. So like 2 important columns. So we have Q for the quotient, R for the remainder. So that way we can organize our numbers. And so we do 2 into 49. So 2 goes into 4 2 times. 4, 0. And then we have 9. 2 goes into 9 4 times. 4 times 2 is 8. And 9 minus 8 is 1. So we get a remainder of 1. And then we write down our quotient, which is going to be 24. And then we divide 2 into 24, which I believe goes evenly because 24 is an even number. So 1, 2, 4. 2 goes into 4 twice, so it looks like 12 times, right? And so we have a 0 remainder, and then we write down 12 for our next value. Divide that by 2, and we see that 2 goes in 12, that's what, 6 times, right? 2 times 6 is 12. And then we have our 0 remainder, because it goes in evenly. So notice that all the even numbers, when you divide by 2, have 0 remainder. And then 2 goes in 6 3 times. So that's going to be a 0 remainder. And then 2 into 3 is 1 time. 1 times 2 is 2. 3 minus 2 is 1. So we get a remainder of 1. And then we got to do 2 into 1. That goes 0 times. And 0 times 2 is 0. 1 minus 0 is 1. So it looks like we get a remainder of 1. And then we write down our 0. 2 goes into 0 0 times. And that gives us a remainder of 0. So just write that to the side. 2 goes in 0 0 times 2 is 0. So now we just write all of our remainders from bottom to top. And that'll give us the final answer for our binary number. So notice that we have all the remainders from bottom to top. So we have 0, 1, 1, 0, 0, 0, 1. And then we have, so we got 0, 1, 1, 1. So we can actually, get rid of the first 0, and then we can just write our final answer is 1, 1, 0, 0, 0, 1. And this would be 49 into binary. And of course, the way to check that is just to go through the powers of 2. So you have 1, 2, 4, 8, 16, 32. And then notice that the ones with ones, we only count, right? So we have the 1. We have 3 ones we need to count. So 1 with 32, 1 with 16, and then the last one is just with 1. So if we add all those together, you get 2 plus 6 is 8, 8 plus 1 is 9, 3 plus 1 is 4. So we get 49, which is the decimal number we started with. So that's a way to check it, to make sure that your answer is correct, is once you convert the decimal number into binary, try converting the binary number back to decimal, the one you started with, just to see if it's accurate. Okay, so this process, the reverse process, converting decimal to binary, actually took a lot more steps than converting from binary to decimal. So let's just review the steps. So we divided the original number by 2. We recorded the remainders that we wrote on this side here. And then we took the quotient, divided that by 2, and then repeated that process until finally we got down to 0 when we couldn't divide anymore. And then we wrote all of those remainders from the bottom to the top. And then if your first digit 0, just cut off the 0 and then write the remaining digits. Okay, so I have 3 problems for you to try. The first problem asks you to convert 1, 0, 0, 1, 1, 0, 1, 1, this binary number into a decimal number. 1, 0, 0, 1, 1, 0, 1, 1 into decimal. Then convert 112, this decimal number, into binary number. And then number 3, we have the on and off switches. What is the decimal number of this on and off, let's say, light bulb set up here? So first one's on, second one's off, third one's on. So what is the decimal number? Feel free to pause the video to work on these 3 problems, and even go back to review part of the video to know how to convert from binary to decimal and from decimal to binary. And we'll go over the answers. Okay, so let's go over the answers. So in our first problem, converting this number into decimal, this binary number in decimal, 1, 0, 0, 1, 1, 0, 1, 1. We're just going to underline each of the digits. and then we'll write out our powers of 2 going from right to left in increasing order. So we'll have 1, 2, 4, 8, 16, 32, 64, and then double with 64 times 2 is 128. And then we circle the powers of 2 that have 1s. So we only add up the 1s, and the zeros don't count. So just remember, 1s are like on, like the on switch is on. You can use them with the light, and then the zeros are off switch. You can't use them because the light's off. And then we just add up all our numbers together. So 1, that's the 128. So that's our largest number. Then we have another 1 at 16. Another 1 at 8. And then a 1 at 2. And the last one is at 1. So we just add all those together. And notice that I wrote them from left to right, because the further left you go, the larger the power of 2 is. So you always write the largest power of 2 first, and then kind of work your way down, so that way you can line up your numbers properly to add them together. So we went from right to left, doing the powers of 2 in increasing order, and then to add them together, we went left to right, just to make the addition easier. So we do 8 plus 6 is 14. 14 plus 8 is 22. 22 plus 2, 24. 24 plus 1 is 25. Carry the 2. 2 plus 2 is 4. 4 plus 1 is 5. And then we have our 1 that we bring down, which is just 1. So this number, 1001111, would equal 155. 155. Now in problem 2, we're asked to convert 112 into binary, and convert 112, that decimal number, into a binary number. So we're going to do 112, do our division house with 2, and then we have our Q for quotient. We have our R for remainder. We'll just kind of set up our boxes here. We know we'll have at least a few to start with. And let's do 2 into 112. So we know that's an even number. So we already know that that's going to be a remainder of 0. It should go in evenly. And we just need to find the quotient. So 2 into 11, 5 times. 5 times 2 is 10. 11 minus 10 is 1. Going into 2. 2 into 12, 6 times. 6 times 2 is 12. 0 remainder, right? So we have 56. And we know that 56 is even, so that divides evenly by 2. So we get a 0 remainder there. And let's do 2 into 56. 2 and 5 is twice. 2 times 2 is 4. 5 minus 4 is 1. Bring down the 6. And 2 into 16, 8 times. 8 times 2 is 16. So we have 28. And we know 2 goes in 28 evenly because it's even number, so that's also a 0. So we're getting a lot of zeros here. And let's see, 2 into 28. How many times? 1, 0 with 8. 2 goes into 8 4 times. So we get 14. And then we know that 2 goes into 14 7 times, so we get a 0 remainder. So let's write a couple more here. I know we have at least a few more to add. So now 2 and the 7, that's an odd number, so we know we're going to get a remainder of 1. So 2, 7, 3 times 2 is 6, so yeah, remainder of 1. So notice that when you divide these by 2, you either get a remainder of 0 or a remainder of 1. So a remainder of 0 is for the even numbers, and if you have an odd number, you get a remainder of 1. So our quotient was 3, and then we know 2 goes into 3 one time. 2 goes into 1 0 times, so we would have a remainder of 1 left over. And I think this will be the end of the road here, because 2 and 2 0, we know 0 times 2 is 0. So we have a remainder of 0. And then now what we do is we're just going to go from bottom to top and write all of our digits. So let's see what we get here. We get 0, 1, 1, 1, 0, 0, 0, 0. And then remember, we can get rid of the first 0. So we have 1, 1, 1, 0, 0, 0, 0. And that would be our binary number, 1, 1, 1, 0, 0, 0, 0. And so the way to check it, just to make sure it's accurate, is you do your powers of 2. You got 1, 2, 4, 8, 16, 32, 64. So the first 3 on the left, those powers of 2, you're going to add the 64, 32, and 16. And the 8, 4, 2, and 1, they're all 0, so we don't add those. 64, 32, 16. So we're just going to add them just to check to make sure we get this number, 112. So 4 plus 2 is 6. 6 plus 6 is 12. Carry the 1. 1 plus 6 is 7. 7 plus 3 is 10. And 10 plus 1 is 11. So we get 112. So that's correct. 112 in binary. 1, 1, 1, 0, 0, 0, 0. And then last but not least is problem 3. What is the decimal number of the on, off, on setup for the light bulbs? So we know that we have 1 is supposed to be on, 0 is supposed to be off, 1 is supposed to be on, so we have 1, 0, 1. And if we look at our powers of 2, we do 1, 2, and 4. So the 4 for this one, 1 for that one, so we just add 4 plus 1 together. It's 5. So we know that 1, 0, 1 in binary is going to equal the decimal number 5. Whew, so that was a lot of work, right? Especially on the second one, that took a lot more division. But let's see what our answer key tells us. So we got 155 for the first one, the 111, 0, 0, 0, 0 for the second one, and decimal number 5. So if you got those answers, well done, great job. You understand how to convert from binary to decimal and from decimal to binary. This is a good skill to have, especially if you're going to work in the field of computers, maybe such as computer science or computer engineering. You'll definitely need to know how to convert your from your binary to decimal and from decimal to binary. And you'll even learn even more number systems as well, besides binary. So this has been McGahee. I want to thank you for watching this video lesson on the binary and decimal number systems and how to convert from one to the other. Please stay tuned for more lessons on YamieChess.com. Have a great day.